Hello and Happy New Year. Today we're going to solve the problem building teams. There are n pupils in a class and m friendships between them. And your task is to divide the pupils into two teams, in such a way that no two pupils in a team are friends. So you're given an example right here. The first two numbers represent n, the number of pupils, and m, the number of friendships. Then you're given m friendships, where each pair represents a friendship between the two numbers given. So I've drawn the graph representation right here. So 1 and 2 are connected, which means there's friendship between 1 and 2, the same for 1 and 3, and 4 and 5. So it's the same as this example. Now, this problem is basically the same as the classic graph coloring problem with two colors. So you're given a graph and you need to color the graph with two colors in such a way that no two adjacent nodes have the same colors. Okay, that is the classical problem. And the technique for solving that is going to be the same technique for solving this particular question. All right, let's take a look at how to approach this. So what we're going to do is to loop from 1 all the way to the last node, n, and explore unvisited nodes with depth first search. So we're going to use DFS. And what we do is at each node, we're going to give it a group, either 1 or 2, that is different from the previous node. I'm going to show that with this example. But if at any point we have two adjacent nodes with the same group, then the answer is impossible. Okay, so let's see what I mean by exploring with depth first search. So we start from 1, we're going to go all the way to 5. All right, so 1 is unvisited, so we explore this with depth first search. So we give it a group. Let me use a different color. So we give it the group 1. Okay, then we look at the children. So let's say we go to 2. All right, the previous node has a group of 1, so we're going to give this a group of 2. All right, so we are done with this. 2 doesn't have any children, so we go to the next child of 1, which is 3. We do the same. The previous node has the group 1, so we're also going to give this 2. All right, so 1, 2, 3, we're done. The next item would be 4, so we had 4. This is an unvisited node, so we give it a group 1. We could also give it 2, it doesn't matter, but let's just use 1 for consistency. And then we run the first search here and check. We find 5. We give it a group different from the previous node. So the previous node has a group of 1, so we have to give this 2. And that's it, we are done. At the end, we're just going to print out the result, which would be 1 for the first one, 1, then for the next 2, we have 2 and 2, okay? And then finally, we're going to have 1 and 2. So these are the groups for the nodes 1, 2, 3, 4, 5. And as you can see, the answer is 1, 2, 2, 1, 2. Basically the same as what we computed. Let's take a look at an example where it is impossible to compute the results. So this is such an example. And let's see how the algorithm works. So we start with 1, give it the group 1. Then we look at the children. So let's say we look at this child next. We're going to give it a group different from the previous node. So we're going to give it 2. Then we come here. and give that 1, okay? Then we come to the next node right here. We're going to give that a different group from the previous one. We're going to give it 2. And then we visit the last node, okay, using depth first search. And we're going to give that a group different from the last node. So we're going to give that 1. However, you could see that at this point, we have 2 adjacent nodes with the same groups. And that implies that the answer to this particular question is impossible. So we just return the word impossible according to the requirement of the quiz. All right, so that's how to solve this. The time complexity is going to be big of n because we're just going to visit each node once to compute this, and the space also is going to be big of n. We need to store the group given to each node. All right, so that's it for the conceptual overview. You can pause the video and try to implement this yourself. We're going to do that next. All right, so let's code this out. Let us create a class building teams. So let's have a run function that will run our program. We're going to do 3 basic things. First, we're going to read in the input. Then we're going to divide pupils into 2 groups using this function. And then finally, we're going to print the result. The first function is pretty straightforward. In the question, we're given the first 2 numbers as n and m. So we're going to read that into these 2 variables. And next, we're given the friendships as a pair of 2 numbers. So we're going to store that as an adjacency list in this vector of vectors. All right, so that's that. Next, we're going to define the function we're going to use to solve the problem. But first, we need 2 variables. So we need the group, a vector of integers to store the group for each node or vertex. And we also need this variable is possible, which will tell us if it is indeed possible to divide the entire graph into 2 separate groups. Okay, so this function is going to look like this. Basically, like I explained in the conceptual overview, you're going to loop from the first node 1 all the way to the last node. And while it is possible to do so, you're going to use depth first search to assign the right group to each vertex. So our depth first search function is pretty straightforward. And what it does basically is if we've already visited a node, then this should not be 0. In that case, we want to make sure that the group of that particular node should not be the same as the previous group. In that case, the answer is impossible. Otherwise, we're going to set the group for that particular vertex to something different from the previous group. Okay, so if it was 1, we're going to set it to 2. If it was 2, then we're going to set it to 1. And then finally, we're going to loop through each child of that vertex and then run the depth first search function on the children, passing in the current group we gave to this node as the previous group. So that's the depth first search function. Once this is done running, then we're going to compute this particular vector of integers which represent the group for each vertex. So once we're done with that, the last thing we need to do is to print the result. a really straightforward function. So if it is impossible, we just print that and return. Otherwise, for each vertex, we're going to print the group we computed, and that's it. Um, that is the algorithm. Let's try this with an example. Okay. So this gives us 1, 2, 2, 1, 2, which is the same as the example results. Let's try to submit this. All right, so that got accepted. Thanks for watching.